So all the IM3 products, our goal is to make all the IM3 products to fall below the noise floor. So we have seen the graph, we have a noise floor and we make measurements with that as a reference. So if you want to have a minimalist, if you want to have minimal impact of all these IM3 products, we have to ensure that the power of all the IM3 products fall below the noise. If they are going to fall below the noise, then the amplifier will automatically reject all the components, considering it to be a noise. So this will improve the SFDR of your system. It will improve the dynamic range as well as it is going to improve the SFDR of the system. However, if the third order terms emerge from the noise floor, if the third order terms are going to become dominating, then your dynamic range will decrease, the SFTR will decrease, and the amplifier will become more noisy. So that is why we clearly make a boundary condition here. Our amplifier design has to focus on such a way that all the IM3 products should be kept either at noise floor or power levels below the noise floor for the particular operating conditions. So you see here, if this is the output noise, so the SFDR, this is going to be the SFDR. So this is the linear region. So this in the linear region, we measure the peak power and the noise floor. So what is the difference we have between the two? That is going to be your SFDR. So SFDR is nothing but signal to noise ratio. But we are giving it a different name because we deal more with noise, and the noise what we call here is third order IM. It is not our usual thermal noise or short noise. It is going to be the noise because of the non-linearity of your amplifier. It is going to be third order IM noise. In actual signal to noise ratio formula, the noise will comprise of short noise, thermal noise, Johnson noise, white noise. We add everything there. But in high frequency analysis, when you talk with respect to the LNA, the noise means it is more likely to be third order IM power. So that is going to act like a noise for your amplifier. So that noise has to be kept at a bare minimum level possible. So to incorporate and explicitly the noise figure and other properties, we are going to define the NOI. NOI is the input noise power in decibels. And we are going to see what is the input power and output power relation from the graph. So from the graph, I can see the del P1. So the difference in power is going to be IIP3 minus the input noise level by 3. Because it is a third order intercept point, the actual thing means we subtract the power, but since it is going to be referred to IM3, the slope is 3, so I'm dividing it by 3. So SFDR is the difference between the input power and noise. The SFDR is very simple. You can see here the difference. So what is the difference between the input power and noise level? That is going to be my SFDR. So this is going to be the difference in power between the IIP3 point and the noise level. Okay.